In this case, you will multiply the powers. You'll multiply the exponents together. So Brandon, you don't necessarily even have to know what something is. For example, let's say you don't have a calculator. You ready, Brandon?
I'm ready.
You're on a desert island.
Sure.
The cannibals are going to eat you unless you can answer this question without a calculator.
I could tell from my dumb knock-knock joke and maybe they'd laugh.
Good luck. So if I have 5 to the 10th power, and then I want to raise that whole thing to the 3rd power. Now, do you want to, and you've got a minute to appease the cannibals. Okay, you don't want to spend that minute going, what's 5 times 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 5?
That was not 10, was it?
Yeah, it was.
It's 5 times 5, then that times 5.
Well, here's what this means. Let me show you a little bit this way.
I have a feeling it's 1,000.
Okay, you guys all understood, it's not. You guys, it's way bigger. You guys all understood this property, right?
1,500.
Stop. We don't care what 5 to the 10th power is. That's what I said. You guys, hang on a sec, Jenny. You guys understand this power, this property, right?
Yeah.
Okay, well, let me show you what this means. 5 to the 10th to the 3rd power means 5 to the 10th times 5 to the 10th times 5 to the 10th. Because exponents mean multiply things by themselves over and over again. Okay?
That's pretty much what I said about variable.
Now for this one, for this property, we just said if you have the same base, you add them together. So what's 10 plus 10 plus 10?
30.
30. Would it have been faster to just multiply 10 times 3?
Yes.
Yes, so that's the rule for that one. You're going to see this with variables. Here's the other problem. You're going to see this, for another example, as something like x cubed, and then that whole thing squared. So how do we write that one now? Jenny?
You write it. Do you want me to do it like the second way, or like do you want me to show all the steps?
Just give me the answer.
It's gonna be x to the 6th power.
X to the 6th power. You multiply the 3 times the 2. Okay? And you don't know what x is. But you do know that if you have x times x times x, and then you multiply that by itself, you're going to get x to the 6th. Okay? If you have to get this right for a while, go ahead and make this x cubed times x cubed. If it'll help, make it x times x times x
What if you did
times x times x times
But
x.
what if you did x cubed, wouldn't that give you whatever x cubed is times the other x cubed, but then x to the 6th, wouldn't that x cubed times x cubed give you a bigger number?
Nope. This will always be the same as x to the 6th, whatever number you plug in. If you don't believe me, go home on your own time, take some numbers, plug them in for x, and try it. Pull out your calculator and put in 2 cubed times 2 cubed. But it will work out the same. Yes, new lady?
So the difference between the first part, like, yeah, the add and the second and the multiply?
Yes, but you got to keep track of which situation is which. 5 cubed times 5 to the 10th. You're multiplying two numbers together. They each have exponents in the same base. Okay? Over here, we're raising... Jordan, man, I'm worried about you. Get some chicken soup tonight. We have a base, a power, and it's raised to another power. And that's when you multiply. Okay, so you got to know which case you're starting with. Here's another property that we're going to do, which your book calls power of a product property. Power of a product property. That's the problem. This would also be POAP, Nick. We'd have the same acronym for this one that we had for the power of a power property.
We could have POAP.
POAP 1, POAP 2, POAP 3. We might have to. This one says, if I've got some number A, and it's multiplied by some number B, and both of those numbers are in parentheses, and the whole thing is being raised to some exponent. Okay? They're different bases. That is going to be the same thing as A raised to this power times B raised to this power. It's a little bit like the distributive property, but it only works when there's multiplication in the parentheses. Does not work if there's any addition or subtraction in there. You won't have any of that tonight, but I will yell at you about that much later in the semester. So for example, if I have, what's your book do here? Okay, that works. If I have 2 times 3, and I raise that to the 4th power, okay? That is the same thing as, Jenny, what is the same thing as?
It's going to be the same thing as 2 to the 4th power times 3 to the 4th power.
Yep.
And that's, do you want me to try to solve that in my
No, that's where you'd leave it. Especially if I give you a non-calculator test on this, that's definitely where you'd leave it. Incidentally, you can do what's in parentheses, so this is the same thing as 6 to the 4th power. But most likely you'll get examples that look like this. You'll get examples where it's like x squared times y cubed. Okay? If you get an example like this, take a look at this. X squared times y cubed. I can make this x squared, whole thing cubed, times y cubed. Why did I leave the x squared in the parentheses? Yes, Brandon?
I was going to ask a question. It's like a kind of a trick. If there was like a number like 6 to the 4th, instead of going 6 times 6 equals this times 6,
Yeah.
couldn't you do 6 times 8 and just double whatever the exponent is to get the answer?
No, that won't work. Ask me again when we start graphing parabolas why that doesn't work. You're trying to make what's called a linear relationship out of something that is not a linear relationship.
That can't happen?
No, that can't happen.
Just trying to find it.
Clever. No, there are no shortcuts. Anyway, this one here, why did I leave the x squared in parentheses, Jordan?
Because it had an exponent already.
Had an exponent on it. And what's the rule for when we got an exponent, we're raising that for a power, Jenny?
You have to multiply them.
You have to multiply it. So that's going to be x to the 6th times y cubed. Y to the 3rd power. You guys know that cubed means 3rd power and squared means 2nd power?
Yeah.
At least some of you have heard that before? Okay. So now, let's look at some examples that get a little bit uglier and involve some variables. Okay. Okay. Now, here's an example. Pulling from the book just to be, I'll change them a little bit. 4 times y times z, whole thing cubed. 4 times y times z, the entire thing cubed.